Next example, obtain the power series expansion of log 1 plus x by Taylor's theorem or Maclaurin's theorem. So by Maclaurin's theorem, fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 x cube by 3 factorial f triple dash 0 and so on. So the given function log 1 plus x as fx, then the value at 0 is log 1 plus 0 is log 0, log 1 is 0. Then f dash x is 1 by 1 plus x, f dash 0 is 1 by 1 plus 0, that is 1. Then f double dash x minus 1 by 1 plus x bracket square is 0. And its simplification is what? 1 plus x bracket raised to minus 2. The value at 0 is minus 1. So its derivative is this, minus minus become plus 2, 1 plus x raised to minus 3. Value at 0 is 2. Then fourth order derivative is minus 6, 1 plus x raised to minus 3 minus 1 is minus 4. And then value at 0 is minus 6. Then substitute all these values in equation number 1. This equation number star, that is fx is log 1 plus x, f0 is 0, x f dash 0 is 1, then x square by 2 factorial f double dash 0 is minus 1, x cube by 3 factorial f triple dash 0 is 2, and next term is x raised to 4 by 4 factorial, fourth order derivative is minus 6, and then we have this is the expansion of log 1 plus x, that x minus x square by 2 plus x cube by 3 factorial into 2 is 3 factorial is 6, 2 by 6 is 3, 4 factorial is 24, and then 6 by 24 is 4, and this minus term, and so on. So these are the problems for homework. Then next is log 1 plus expand log 1 plus x divided by 1 minus x. So log 1 plus x divided by 1 minus x by log a by b rule, log a minus log b. And log 1 plus x, this is the expansion. Log 1 plus x is this, x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 and plus so on. And the expansion of log 1 minus x, just replace x by minus x in this. So we have this term is minus x, and minus x square is plus x square. So it is minus x square by 2. Then this is minus x cube by 3 minus x raised to 4 is plus x raised to 4. So minus remain minus. So this is the expansion of log 1 minus x. Just replace x by minus x in the expansion of log 1 plus x. So we have this. Then after negative sign, all the terms become positive. And then this x plus x become 2x. And this x square by 2 minus x square by 2 and plus x square by 2 become 0. Then x cube by 3 and x cube by 3, the addition is 2 times x cube by 3. Similarly, this minus x raised to 4 by 4 and plus x raised to 4 by 4 become 0. The next term is obviously plus x raised to 5 by 5, and here plus x raised to 5 by 5 becomes 2x raised to 5 by 5 and so on. So if we take 2 as common, then this is the expansion of the log 1 plus x divided by 1 minus x. Then expand 1 plus x raised to m. M is integer. Okay, so fx as 1 plus x raised to m. Then the Maclaurin's theorem is this: fx is equal to f of 0 plus x f dash 0 plus x square by 2 factorial f double dash 0 x cube by 3 factorial f triple dash 0 plus so on. This is equation star. And then the given function is fx 1 plus x raised to m. Then the value at 0, that is substitute x at 0. So we have the answer 1. Then f dash x is m 1 plus x raised to m minus 1, and f dash 0 is m, that is substitute x at 0. So we have m value. F double dash x is m minus 1 1 plus x raised to m minus 2. And the value at 0 is m minus 1. In this way, f triple dash x is m minus 1 m minus 2 1 plus x raised to m minus 3 m minus 2 minus 1 become m minus 3. And the value at 0 is m minus 1 m minus 2. And all substitute all these values in equation number star. We have fx as 1 plus x raised to m is equal to f0 is 1. Then f dash 0 is m, f double dash 0 is this, and f triple dash 0 is this. So we have this step. Okay, and then this is the expansion, that 1 plus mx plus m minus 1 by 2 factorial x square, then m minus 1 m minus 2 by 3 factorial x cube. This term is what? m minus 1 m minus 2 m minus 3 divided by 4 factorial x raised to 4 and so on. Okay, so this is the expansion of 1 plus x raised to m. Then obtain the power series expansion of 1 plus x raised to minus 1. That is just substitute m as minus 1. So we have this answer. If we substitute m as minus 1, we have 1 minus x, then m minus 1. So this become again 2. 2 factorial and divided by 2 becomes 2, 1, and therefore x square. Then m minus 1, m minus 2 become minus 6, and this divided by 3 factorial means 6, becomes minus x cube. And then similarly, we have the term x raised to plus x raised to 4 minus x raised to 5 and so on. So 1 plus 1 minus x raised to f, the expansion of 1 minus x raised to f. Just substitute x as minus x. So we have the term 1 minus mx. This term a minus x square becomes plus x square. So this term as it is, then this term becomes minus this term x cube minus x cube is minus x raised to 3. So this is the expansion of 1 minus x raised to f. And if we obtain 1 minus x raised to minus 1, then we have this. Expand fx is equal to root 1 plus x. Answer is this. So root 1 plus x means 1 plus x raised to half. So I write Maclaurin's theorem, fx is equal to f of 0 plus x dash f of f dash 0 x into f double dash 0 x f dash 0, then plus x square by 2 factorial f double dash 0. This is not dash, x square by 2 factorial, x cube by 3 factorial f triple dash x and so on. Then fx as 1 plus x raised to 1 half. Then its value at 0 is 1. F dash x is 1 half, 1 plus x raised to 1 half minus 1 is minus 1 half. Then value at 0 is 1 half. F double dash x is this. That is 1 half, and this minus 1 by 1 half becomes minus 1 by 4, 1 plus x raised to minus half minus 1 minus 3 by 2. Then value at 0. Similarly, the third order derivative, minus 1 by 4 and minus 3 by 2 becomes 3 by 8, 1 plus x raised to minus 1, minus 3 by 2, minus 1, minus 5 by 2. Then value at 0. Similarly, the fourth order derivative value is minus 15 by 6. 60, then put all these values in equation number star, then root 1 plus x is what? 1 plus, that is substitute f0 is 1 plus x f dash 0 is 1 half plus x square by 2 factorial f double dash 0, x cube by 3 factorial f triple dash 0 plus x raised to 4 by 4 factorial f raised to 4 0, and we have this answer, final answer. Okay, so this is the expansion of root 1 plus x. Then fx is tan inverse x, expansion of tan inverse x. F of 0 is tan inverse 0 is 0, because tan 0 is 0. F dash x 1 by 1 plus x square, derivative of tan inverse x. Then f dash 0 is 1. Then its simplification, 1 by 1 plus x square means its derivative minus 1 by 1 plus x square bracket square into 2x, right here 2x into 2x, because the derivative of x square is 2x. So write 1 minus 1 by 1 plus x square bracket square into 2x, and then again its derivative. So this is wrong calculation, right here into 2x. Then write obtain f triple dash x by using u into v root or u by v root. That 2x and this 1 plus x square bracket square means 1 plus x square raised to minus 2. It's simplification, right here 2x, and then find f triple dash x by using u into v root. So correct the problem, answer of this problem. Then next problem is, this is about the Maclaurin's theorem and Taylor's theorem power series expansion. So next topic is successive differentiation. That is the higher order derivative, nth order derivative. So y is equal to fx is the function, then its first order derivative is denoted by y1. Y suffix 1 means its first order derivative, that is dy by dx. Okay, and is f dash x, another notation is f dash x. And the second order derivative d square y by dx square, or y2, and is f double dash x, second order derivative. In this way, y suffix n means yn is what? The nth order derivative of the function f raised to n x. So this is the notations for derivative of first order, second order, and nth order, that is y1, y2, yn. Then derivative of some standard functions. First number ax plus b raised to n, nth order derivative. We have to find the nth order derivative of this So the question is, if y is ax plus b raised to m, then find yn. That is the nth order derivative. So y1 means its derivative is what? M ax plus b raised to m minus 1 into derivative of ax plus b is a. So a into m ax plus b raised to m minus 1 is y1. Then y2 is what? Again am is constant, and derivative of ax plus b raised to m minus 1 is what? M minus 1 ax plus b raised to m minus 1. Minus 1 means m minus 2 into derivative of ax plus b is a. So it's y2 is a square m minus 1 ax plus b raised to m minus 1. Then y3 a square y, if we find y3, then it is a cube m minus 1 m minus 2 x plus b raised to m minus 2. In this way, yn is a raised to n m minus 1 m minus 2 m minus in bracket n minus 1. If we observe y3, the coefficient last bracket is what? M minus 2. M minus 2. That is, if there is 3, then it is m minus 3 minus 1. 2 is what? 3 minus 1. So y1, yn, the last bracket is what? M minus in bracket, right, in bracket m minus n minus 1, or right, m minus n plus 1. Ax plus b raised to, if you observe y3, then it is m raised to m minus 3. Correction is here, right, m minus 3. If we observe y2, then it is ax plus b raised to m minus 3. If we observe y3, then ax plus b raised to m minus 3. So here ax plus b raised to m minus n, yn is. And the simplification is a raised to n. This m minus 1, m minus 2, m minus n plus 1, ax plus b raised to m minus. So write this as the last step. Don't write this step as the last step. Then ax plus b raised to minus 1. The expansion of ax plus b raised to minus 1. Just substitute m as minus 1. So we have a raised to n. Here just substitute m as the minus 1. Minus 1 into minus 2 into minus 3 into m as n minus n. So we have substitute m as minus 1. Minus 1 plus 1 becomes 0. So we have the last term minus n. X plus b raised to minus 1 minus n. Minus 1 minus n. That is, just substitute m as minus 1. So we have this. And this is what? Minus 1 raised to n. And this is 1 into 2 into 3. So if you write minus 1 as a minus 1 into plus 1, minus 2 as minus 1 into plus 2, minus 3 as minus 1 into 3, and this is minus 1 into n. And so minus 1 minus 1 minus 1 n times becomes minus 1 raised to n, a raised to n, and this is 1 into 2 into 3 into n, that is n factorial next step, x plus b raised to minus n plus 1 in bracket. Okay. So we have this minus 1 raised to n, a raised to n factorial, x plus b raised to n plus 1. It is not n minus 1, n plus 1, divided by n plus 1. So this is the expansion of 1 by 1 plus 1 by ax plus b, or ax plus b raised to minus 1. Or not expansion, it is nth order derivative. Then next example is y is equal to a log ax plus b. Log ax plus b. So y1 is first order derivative is log ax plus b. 1 by ax plus b into derivative of ax plus b is a. 1 divided by x plus b into a. And so it is a by ax plus b. Then y2, the derivative of what? This quantity. A is constant, and 1 by ax plus b, derivative is minus 1 by ax plus b bracket square into derivative of ax plus b is a. Right, into a here. Right, into a, and this a into a become a square. Because of minus 1 we have negative side, ax plus b raised to 2. In this way, to find y3, y4 and so on. So find write y3, y4, y5, and then we have yn as this, that minus 1 raised to n minus 1, n minus 1 factorial ax plus b raised to n. So we have this. That is y3. Next is y3, right? y3, then y4, and then yn. Yn is this. Then y is a raised to mx. Then find yn. So y1 is a raised to mx uh, into log a. Into the rate of mx is m. So a raised to x. What is the derivative of a raised to x? A raised to x into log a. And it is a raised to mx. So derivative is a raised to mx into log a into derivative of mx is m. So m a raised to mx log a. Then y2 is what? Again the derivative m and log a constant. M and log a constant. And a raised to mx derivative is a raised to mx into log a into m. So m and m becomes m square. A raised to mx log a bracket square. Already it is log a, and log a into log a is log a bracket square. So here is log a bracket square. Then y3 is what? M cube a raised to mx log a bracket cube. And in this way, here is the correction. Yes. Y2 is m square log a bracket square a raised to mx, because m log a is constant and a raised to mx derivative is a raised to mx log a into m. Mx derivative of mx is m. So it becomes m square log a bracket square a raised to mx. Then y3 is what? Y3 is m cube log a bracket square is constant quantity, and derivative of a raised to mx is what? A raised to mx log a into m. So it becomes m cube log a bracket cube a raised to mx. And in this way, yn is what? M raised to n. Y3 is m raised to 3. So yn is m raised to n log a raised to n. Y3 log a bracket cube. So yn is log a bracket raised to n a raised to mx. So this is the nth order derivative. So these are the nth order derivative of some function. Nth order derivative of some function. So there are some another functions that sin ax plus b. I have to find the nth order derivative of sin ax plus b, cos ax plus b, and all the remaining problems. So I will share the remaining nth problems through WhatsApp, and we will discuss these problems in the next lecture, remaining problems of nth lecture. So next theorem is Lebanese theorem, and this is important that if u and v be two functions possessing derivative of nth order, then y is equal to u into v, then u into v n, that is nth order derivative of u into v is what? U into v is right here, y is equal to u into v, then yn is, that is u into v, n is nth order derivative is nc0 unv plus nc1 un minus 1 v1 plus nc2 un minus 2 v2 plus so on, plus ncr un minus r vr plus ncn uv, where ncr is n factorial, n minus r factorial into r factorial. Okay. So this is the Lebanese theorem. That is, if y is the multiplication of two functions u into v, then its nth order derivative is what? This is the nth order derivative of that function. Y is equal to yn is equal to this, the nth order derivative. Okay. So this is the so what are the use or application of Lebanese theorem? In if y is multiplication of two functions, and if you have to find the nth order derivative of multiplication, then use the Lebanese theorem in order to find the derivative of multiplication of two, nth order derivative of multiplication of two functions. So we'll see the proof of the Lebanese theorem and the remaining problems of nth order derivative in the next lecture. The remaining problems are what? Y is equal to sin ax plus b, cos ax plus b, then find yn. So we'll see the remaining problem and the proof of the Lebanese theorem in the next lecture.